So this should be a fairly quick video. This is going to be a video about introducing us to the second of ultimately three forms for writing linear equations. We're already very familiar with the first of those three forms, slope-intercept form. Whoops, let's try that again so I don't cross it out. Slope-intercept form. And we know that as y equals mx plus b. And we know the m is the slope, and we know the b is our y-intercept. Our new form, called point slope form, is going to take on a slightly different look. Our new form of point slope form is going to be this formula right here. Y minus y1 equals m, which we're familiar with the slope, parentheses, x minus x1. So again, we already know that the m in this is our slope, okay? So there's our m, and it represents slope. What's a little bit new to us is this notation of x1 and y1. Those are going to become placeholders, as we'll see here, for values of coordinates for x and y for a given point. Okay, so when we write an equation, we're going to have to, well, one way of writing an equation in point slope form is to be provided the slope, m, and to be provided an ordered pair, which we will recognize as an x coordinate known as x1 within the formula, and a y coordinate known as y1 within the formula. And we will essentially have those three pieces of information to substitute in and to leave the equation as is. It'll be awfully tempting, and I'll say this right now, it'll be awfully tempting to want to do some further simplifying, particularly since we see parentheses with that value of m directly outside. It's going to be really tempting to want to distribute, but we're going to resist all temptation to do so, okay? So let's start with an example. In point slope form, if that's what we're asked to do, once again, we need to know that our equation is going to be y minus y1 equals m parentheses x minus x1. Now, as long as I have the m provided to me, which I do, there's my slope, there's my m, and as long as I have an ordered pair given to me as x1, y1, and I do, there's my ordered pair, x1, y1, I have everything I need to write my equation, so I can go ahead and do so. And it's going to be a simple matter of substituting in. So we're going to say y minus, now our y1 value is -3, so we're going to say minus -3, is equal to, and our slope is right here, 2, parentheses, x minus, and our x1 value, our x coordinate from our given ordered pair, is 4. Okay, so I'll outline that. So here's our slope, our 2. Here's our x1 value right there. Here's our y1 value right here from our given ordered pair. So we're almost done. Like I said, we're going to resist any temptation at least to do any distributing here. But we will always, when we have the opportunity to, we will always get rid of this minus and negative. So the only little bit of cleanup we're going to have to do is right there. We're going to change that from minus and negative to saying plus. So our final equation is going to be y plus 3 equals 2, parentheses, x minus 4. So that is the equation in point slope form of the line with the slope of 2, of a slope of 2, and an ordered pair representing the point 4, -3. That's it. We're done. So I'm going to ask you to repeat the process for the next two examples. I am going to move on, so you'll continue these two examples on your own, just simply substituting in quickly for x1, y1 in each case, and substituting in for m in each case, and getting rid of the minus and negative where applicable, and just leaving your equation in point slope form, resisting all temptation to do any other simplifying. Okay. The other way, if we're not going to be given the information explicitly by way of an ordered pair and the slope, the other way that information can be provided to us is by way of a graph. So I'm going to use this example right here, as a way of extracting the slope, extracting the x1, y1, and quickly writing my equation. So I can already see I have a starting point that's been marked for me. It looks like the slope has been counted for me and has actually been uh, solved out. So it looks like they must have counted a rise down of 7, a run to the right of 3. So there's our slope of negative 7/3. It also has an ordered pair provided to me. It's a little bit tough to see, but the ordered pair that's already marked, or the point that's already marked in the ordered pair looks like it's negative 3, 4. So I know that's my x1 and my y1 value. So I have everything I need. I can quickly rewrite my formula. And for now, I'm just going to start by rewriting it every time, just until I get it embedded into memory. And then I'm simply going to substitute everything I know. So I'm going to go y. Let's see, it's going to be minus my y1 value of 4 equals my m value, which is my slope, negative 7/3, parentheses, x. Now here, I don't have to worry about writing minus and negative only to change it. Since it's minus and negative 3, I know that's automatically going to default to plus positive 3. And once again, we'll resist all temptation to do any other simplifying. Here's our final equation in point slope form. Y minus 4 equals negative 7/3 parentheses x plus 3. And that is based on this graph line that had a slope of negative 7/3. There's my m. And passed through the given ordered pair of negative 3, which shows up as plus 3 because of the minus and negative, and positive 4, which shows up as the minus 4 after the y. That's it. So one more time, I'll leave it to you to write the equation in point slope form for this graph. You notice the rise is already given to us. There's my rise, in case you're confused. There's my run. There's my ordered pair. So you're good to go. And we'll come to class tomorrow and continue our practice.